Alright, today we're discussing formulas. Some of these are going to be a little bit of geometry equations. I don't know if some of you may remember geometry from any other math classes you've had before, but you'll see that, we're just going to talk about perimeter really for our geometry problems, and then we're going to talk a little bit about how to change and manipulate some formulas. For perimeter, anytime you're asked about perimeter, it doesn't matter what the figure is. If it is, if I could spell today, it is going to be adding up the sides. So if you have any type of figure, whether it's a triangle, whether it's a rectangle, whether it's got 5 sides, if you ask to find the perimeter, you're going to add up the sides. So we have a triangle here, and we see that our perimeter is a plus b plus c, if that's what you want to call your sides. So if we're going to figure out the perimeter of this triangle, we're going to add 5 plus 6 plus 8. That's going to give us 11 plus 8 gives us 19 inches in all. That would be the perimeter of this triangle. Now I could give you the perimeter. Look at the next example. I'm going to give you the perimeter, and I'm going to ask for a missing side. So we're going to just take, remember the perimeter is our total. Let's just subtract off each side, and what we have left over is going to be equal to that missing side. So if I take 32 minus 10, that'd be 22 minus 15, that's going to give me 7 inches for that missing side right there. So you can see perimeter is pretty easy to work out. Let's look at this one at the bottom. Suppose the perimeter, well, in the middle it says write the formula, so a plus b plus c. Okay, so the perimeter of a triangle is 98 inches, so they didn't draw the picture this time. So that equals my p. The length of 2 sides are 23 and 35. Find the length of the third. So the easiest way, I think, is just to take 98 minus 23 minus the 35. And what we have left is going to be equal to our missing side, which comes out to be 40. That would be our missing side. You could take 40 plus 35 plus 23 and double check yourself and make sure that that equals up to our 98. Okay, now let's look at some variable problems, and these are solving for variables, and these will come in handy if any of you are going to be taking our technical classes. A lot of formulas involved, and sometimes it's nice if you can take a little bit of a shortcut and solve for a variable instead of having to work it a longer way. If you know how to solve for a variable, sometimes it makes the problem easier. Same thing in nursing. If you have a lot of formulas in nursing to know, and if you can make your problem to where it's a little bit easier to plug in your numbers, then let's do that. So we're going to use the same rules as solving regular equations, meaning, you clear fractions if we need to clear any fractions. We are going to get the variable that we want by itself, okay? So get the variable we need by itself. And so a lot of times I will circle that variable, because what it is we're going to solve for a letter. Now, that means that the numbers that we have in these formulas will stay in the formula. They're just going to be manipulated and moved around. We're not going to have a happy little x equals 2 in these. So for instance, if I want to solve for r, okay, so v equals I r, and I want to solve for r. So r is going to stay put. It's frozen. I need to look and see on the side that has the r, what do I need to move? Well, the only thing with that r is an I, and it's I times r. And when we're solving equations, we always do the opposite. So if it's multiplication, if I divide both sides by I, then I can cancel out that I that's with the r. And then just rewrite what you have. It's going to look odd, but just rewrite it. So v over I equals the r, and I've just solved the r. I know that they look odd, but that's just the way they are when we solve formulas. This next one we're going to be solving for y. Now this is going to be important when you get to the graphing chapter, and we have to do some graphing. So I want y to stay put. So y is frozen. I need to move 3x away from y, and I need to move the 4 away from y. Well, anytime we're solving equations, we do adding or subtracting first. We save division for last. That's what's going to happen with the 4. So I'm going to subtract 3x from both sides. That's going to move that 3x over here with the 8. So I'm going to have 4y equals negative 3x plus 8. Now I could have written that 8 minus 3x. It would have been the same problem. It would have been just fine. Now I need a 1y here, not a 4y. So I'm going to divide by 4. So I could just divide all of that by 4. As long as you put everything with the 4 underneath it, that's good. So this is one way I could write it. Or if I want to put a 4 underneath each one of those, I could have negative 3x over 4 plus 8 over 4. I could do that. And if I do that, the computer or probably is going to want me to reduce that 8 over 4 to 2. So again, you can write that either way and that will be correct. Now, these at the bottom are a little bit different because they've got these fractions in them. So remember, we're following the same steps that we're doing if we're solving regular equations. So we would want to clear that fraction. So on this one, if I want to clear 5/4, since it's the only fraction I have, I can multiply by its reciprocal. So I'm going to multiply by 4/5. If I do that over there on the right side, I need to come over here and do it on the left. So I have 4/5 equals, that would cancel, p minus r. Now my problem is telling me to solve for p, so p is staying put, it's frozen. I need to move minus r, so I'm going to add r to both sides. There's a d there that I forgot. So, rewrite what you have. 4/5 d plus r equals p. And now I've solved for p. This next example down below it, same way. It's got a 2/3 in front of it. So I'm going to rewrite it so I can have a little bit more room and I'm not so squished up. So to get rid of the 2/3, I'm going to multiply by 3 over 2. So 3 over 2w equals, those would cancel, r minus 26. It's asking me to solve for r, so it's going to stay frozen. So the opposite of a minus 26 would be plus 26. So 3 halves w plus 26 equals r. So I've just solved for r. Now, some of them are not going to be as involved as that. Let me just pull up a blank page and let me show you some other examples. If we had distance equals rate times time, that's a pretty common formula, and I want to solve for t. Well, the t is going to stay put. I have an r times a t, so divide by that r to cancel it out. So d over r equals my t. That's a good example. Another example, let's go back to perimeter equals a plus b plus c. And let's suppose I want to solve for b. So b is going to stay put. I have a plus a and a plus c. So the opposite of those would be subtraction. So I'm going to subtract a and I'm going to subtract c from both sides. Now, you're just going to have to kind of be careful and write this in a line. So I'm taking p minus a minus c, and that would be equal to my b. And so those are the types of formula problems that you're going to see. Have a great day.